Unit 2, Polynomials and Polynomial Functions. 2.1, Use properties of exponents.
The vocabulary is listed.
These are just some of the key concept tables from the lesson 2.1, some of the different properties of exponents that you can have. Scientific notation. Example, 85 million locusts per square kilometer cover 12,000 square kilometers. How many locusts are there? So your number of locusts equals your locusts per square kilometers times the number of square kilometers. So in this example, 85 million times 1,200. You would then simplify that down to 1.02 times 10 to the 11th for scientific notation. Test practice. What is the simplified form of that equation there? You have x to the negative third, y to the third squared over x to the fifth, y to the sixth. So using some of the key concepts, some of the properties of exponents from the key concepts table listed before, you would end up with 1 over x to the 11th.
2.2, Evaluate and graph polynomial functions.
Vocabulary is listed.
This is pretty much the major key concepts for the lesson. Direct substitution, which, as listed, you pretty much take the listed x value and plug it in for x directly and end up with 23 for this equation. And for synthetic substitution, you almost do the same thing, except for the x value, you plug into the house almost, and it goes with all of the numbers from the equation, and if there is, the degrees have to be in order, like numerical value, and if they're not, you have to add in a 0. However, it goes down and ends up with 23 as you had in the last one. And for graphing polynomials, you do the same thing with making a table, however, use direct substitution. Key concept as listed. So for these, you kind of want to explain a little bit more because it gets a little difficult to understand. But the odd negative is always going to go from up to down because it's an odd negative. Odd positive is going to go from up to down, but this way. And even positive is the two ends, and even negative is the two ends down here.
2.3, Add, subtract, and multiply polynomials. The one vocabulary term is listed below. For adding, subtracting, and multiplying polynomials, you basically, the only one I'm going to go over is the subtracting polynomials, because when you subtract polynomials, you're technically adding polynomials and changing around the signs. So for this equation, you have a large polynomial minus a smaller polynomial. So to subtract it, you would change the sign in the middle of the two polynomials to a plus, and then change all of the signs in the second polynomial from plus to minus and minus to plus. And basically you're just adding from there. And it's just like adding your regulars, different terms with the same exponents. And for multiplying, it's just like a big long FOIL when you do it horizontally. It can be done vertically, but horizontally is just a FOIL on steroids. Key concept table. These are just some special product patterns that you can have with different types of monomials that you can multiply out for.
2.4, Factor and solve polynomial equations, and the vocabulary for this lesson is listed below. So one of the key concepts you're going to want to know for this is the factoring polynomials and how it can be factored completely. And another one is the special factoring patterns for these, like the sum of two cubes and difference of two cubes. So factor two cubes. As you can see, there's the example, which is x plus 3 and plus 64, which can factor out with the sum of two cubes and the extra one down here if you want to actually solve it. But there's combined factoring, in which you take the equations that we have listed below, and you can factor it out completely with the factored amounts here. But when you have an x to the fourth in an equation as a leading variable, and exponent, factor the expression just like an equation, except put x squared for each answer instead of x. And factor by grouping is probably one of the easiest because you have the equation that you have, but you also want to take out a common factor and simplify it out. But whenever you're doing this, these two parentheses always need to be the same, and which you'll take the 2 out and plug it into the equation. And since this is a difference of 2 squares, they would simplify out to x minus 4 and x minus 3.
2.5. Apply the remainder and factor theorem. Vocabulary is listed below. Key concepts, theorems. The remainder theorem and the factor theorem are just a couple different types of theorems that you can have that can help you solve something, usually using synthetic division. So this is basically long division and then synthetic division. It's a lot simpler to use synthetic division, I think, because it gives you your answer quicker. When you have long division, you have to keep plugging it in like you would regularly divide like a number, except you have to divide it out to the whole entire polynomial that's being divided. For synthetic division, you just plug in, you have a factor of x, which in this case is x plus 3, and you plug in a negative 3 on the outside of the little box, and you practically use synthetic to just find your answer. And for the end, you have to put your remainder and your equation over the other factor so that you get your answer and your remainder. When you factor a polynomial, you can use synthetic division as well, because when you have synthetic division, you just need something like you need a factor of x plus that of the equation, and you can sub it in, and if you get 0 for your answer, then you can use that. In this case, you would have 3x squared minus 10x minus 8 as your leftover. You can use that and just factor it out using the x method or the asterisk method to find.
2.6. Find rational zeros. The vocabulary is listed below. The key concept for this really is the rational zero theorem, and for this you're definitely going to want to be best friends with this, because the P over Q is like your thank yous and pleases and stuff like that, because when you're doing this, you're going to want to make sure that you're comfortable with leading coefficients and the constant terms, because those are going to be your best friends. When you're doing this, you're always going to look at the constant term and list the factors for it. However, when you're doing the factors of the leading coefficient, it's only going to be 1 because it's an x. In this case, if it was a 2 or a 3, you'd always do the factors following for that. But when you're going to find the possibles, you would always do 1. You'd always list the constant terms. But if you have a second variable, right, or a second numerical value right here, you're going to want to divide all these numbers by that number as well. Find zeros when leading coefficient is 1. So like before, you're going to want to go through and use synthetic. However, if it does not come out to 0, like this right here, when you're using 1, then it's not going to be the factored 0 or the rational 0 of it. In this case, negative 1 is, because it comes out to 0 down here. And the steps are listed, as you can see.
2.7. Apply the fundamental theorem of algebra. Vocabulary is listed below. The fundamental theorem of algebra. The theorem is listed as is a corollary. More theorems. You have the complex conjugate theorem and the irrational conjugate theorem. So an example for this one. To find the zeros of a polynomial function. The steps are listed below. To apply these steps, you just have to write a polynomial function f of at least a degree that has irrational coefficients, a leading coefficient of 1, and 3 and 2, and 3 and 2 plus radical 5 as zeros. So you would have that following equation. You would write in f of x in factored form, regroup terms, multiply, expand your binomial, simplify, multiply, then combine your like terms. To check if this is right or not, evaluate f at x with each of the 3 zeros. Thank you for watching our polynomial video.